Section 7.3, we're going to be looking at power reduction formulas in this video. So if you have a calculus problem with a sine squared or a cosine squared in it, and you really, really need the trig function to not be squared, these formulas are the way to go. And these are both just rearrangements of those cosine double angle formulas that we already learned about in class. So this is a typical situation that you run into in your calculus class. You've got sine to the fourth x, and you can't work the calculus problem with exponents on your sine function. So we're going to use our power reducing formulas to rewrite this in a useful format for calculus. So I've got sine to the fourth of x, and I have a formula for sine squared, not sine to the fourth. So I'm going to think of sine to the fourth as sine squared squared, or sine squared times sine squared. So I'm going to say sine squared x times sine squared x. So I know sine squared theta down in the box, so all I'm going to do is replace theta in that formula with x and use it twice. Okay, so I know that sine squared x is going to be equal to 1 minus cosine 2x over 2. And I'll use it again for the other one. Sine squared is equal to 1 minus cosine 2x over 2. And at first glance, it looks like I've done what they asked me to do. Rewrite sine to the fourth in terms of the first power of cosine. All of my cosines that are sitting there look like they're to the first power, but they're really not. So if I put parentheses around the top here, you can see when I multiply these fractions together, I've got this FOIL, or multiplying out 1 minus cosine times 1 minus cosine. And when I do that, I am going to get a cosine squared. So I've reduced the power down to a square, but I still haven't gotten it down to the first power. So I'm going to FOIL out the tops of those fractions. I'm going to do, my first terms give me 1 times 1. Outer term gives me minus cosine 2x. Inner term gives me minus cosine 2x. And last, negative times negative gives me a plus cosine squared 2x. All of that over 2 times 2, which gives me 4. All right, so I can combine my cosine 2x's in the middle. All of that over 4. Okay, so it's certainly better than it was in terms of exponents. I used to have something to the fourth. Now I've got something squared. All right, so now I've got cosine squared. So I'm going to have to go down and use my cosine formula. But I've got cosine squared of 2x inside. So now 2x is going to be taking the place of theta. So that cosine squared formula says whatever that theta is, over on the right-hand side, you're going to multiply it by 2. All right, so my theta is now 2x. So my formula on the right-hand side, 1 plus cosine, is going to be cosine 4x. Whatever that theta is gets doubled in the formula. So I'm going to replace cosine squared 2x with 1 plus cosine 4x over 2. And this is going to give me a kind of ugly looking complex fraction. So I'm going to have 1 minus 2 cosine 2x. I'm not doing anything to that term except copying it. And then my cosine squared 2x turns into this big fraction with a cosine 4x in it. So 1 plus cosine 4x divided by 2. All of that is in the numerator over a 4. Okay, so I've actually done what they asked me to do. Everything is in terms of the first power of cosine. I no longer have any FOILs that are going to create cosine squared, but I have a complex fraction, which means a fraction within a fraction, and I want to get rid of that. So I'm going to use a neat little trick here. I'm going to multiply the top and the bottom of this fraction by 2. And I'm doing that because that's the denominator of that complex fraction part. All right, so I'm going to distribute a 2 to this fraction, which is going to wipe out the denominator. And so I get rid of that little fraction. But then I also have to distribute a 2 here and a 2 here. So I get 2 times 1. And then I'm going to have 2 times negative 2 cosine x, so negative 4 cosine 2x. And then that fraction is just going to have its denominator wiped out by the 2. So I'm just going to have plus 1 plus cosine 4x. And then 4 times 2 on the bottom gives me 8. And I'm almost done. All I need to do up in that numerator is to combine the 2 and the 1, the single constants that are there. So I get 3 minus 4 cosine 2x plus cosine 4x divided by 8. And that is the same as sine to the fourth x all in terms of the first power of cosine. And I know you're looking at that right now thinking there's no way that that's going to make my life simpler in calculus, but I promise that it will.